says use the distributive property. And we talked about the distributive property going both ways. So this is an example of the factoring distributive property. Is it Gibran? Is this the one you wanted?
Yeah.
Okay. So we are going to kind of undistribute this. So we're going to factor it. So I look at this. What do both terms have in common?
X squared.
So I'm going to write down x squared. And then I'm going to put a parentheses. And what's going to go in the parentheses? A plus D. Now, if I want to make sure this is correct, I can distribute it back, right? And if I take x squared times both of these, I should end up with what I started with. All right, who else had a question? Bumgardner.
Mine's about like the bounded and unbounded.
Okay, give me a problem number.
Okay, 29.
29.
I just don't know how to tell this.
Okay, that's vocabulary that we didn't discuss, and I'm not going to hold you to, but since you asked, I'll go ahead and explain it to you. Bounded means that it is contained. So if you have drawn it on the number line, and you've got something that looks like this, or like this, it really doesn't matter. If it's contained, then it's called bounded. If you've drawn something that looks like this, then that is not bounded, because this goes on forever and ever and it's not contained. Okay?
So that one would be, 29 would be bounded.
Yep.
And then 31 we had to tell right too. That would be unbounded?
Yep.
Okay. And then terminate for the first and third. How did you tell that again? Terminate?
What's the word terminate mean? She's looking at question number 1. It stops. So if you use your calculator or divided by hand and the decimal stopped, you did the division and it stopped, it's terminating. If you got something like 0.1, 2, 3, 3, 3, 3, 3, 3, 3, 3, 3, then it repeats.
Number 22.
20 what? 2. 22 says, what am I doing? Use interval notation to describe x is positive. Okay, boys and girls, what does positive mean? That it's greater than 0. So if I have to use interval notation to describe greater than 0, how do I do that? Interval notation. What's going to go here?
I did 0, comma, infinity.
You did right. Get open on both ends, right? Get open on both ends. Perfect. That's it. That's the interval from 0 to infinity. You still look like you still have a
I'm
question.
just confused why there's a 0.
Because what does positive mean?
That it's greater than?
That it's greater than 0.
Okay. Oh, okay.
Positive means greater than 0, so that's my starting point.
For a problem like that, does it matter what side the dot is?
Yes. The question is, for a problem like this, does it matter what side the infinity's on? And the answer is absolutely. When you do interval notation, groupies, you must list the numbers in the same order they would come on the number line. So when I shade this on the number line, I'm going from 0 to infinity. Infinity's out here, right? So that's the order they have to come. If I had done this, what's over here? Negative infinity. So my interval would be negative infinity, comma 2. They've got to go in the same order they come on the number line. It doesn't make sense to anybody otherwise. Okay?
Can you do number 51?
51.
That's the only one I left blank. Yeah. I tried.
Okay, 51 is one of our exponent problem. So let's everybody pay attention now. We're going to do an exponent problem. Okay, there are many beautiful things about math. But one of the most beautiful things about math is that you don't all have to do it the same way. So I don't want this to become confusing, but not all of you are going to look at this and think the same thing. The good news is that's okay, as long as we all end up with the same answer, okay? So, who asked about this problem? All right, Baumgartner, tell me how you started. What occurs to you to do first? There are lots of things we could do. What occurs to you to do first?
Well, when I tried it on here, I took -3 times -4 the exponent.
So you decided that you were going to kind of distribute that exponent times both of these things?
Yeah.
Okay? So Katie needs to remember, if that's how she's going to start, she needs to remember that if we're going to take x to the -3rd to the -4th, what are we going to do with these exponents? Multiply them. Okay, if we have forgotten that, we need to remember it. When we raise something to a power to another power, we multiply. So that's going to become x to the 12th, and similarly y to the -8. Now, what about the denominator? Can we do the same thing? And it would make sense to do that since you did the numerator. So that would be y to the, careful, -12, x to the +8. Maya.
So when do you add the exponents?
You add the exponents in a problem where you have something like x to the 6th times x to the 2nd. See the difference? It's an x times an x. That's different than this. Okay, so now I'm here, all right? So what makes sense now? Veronica, do you have an idea, given that we're at this point now, what makes sense to do next, maybe? Well, absolutely, I want to simplify. So what would that look like? What would I do? You're exactly right. I need to simplify it. You see this negative exponent? Does he bother you at all? Yeah, he bothers me hugely. So I might take this negative exponent and do what with it? What do I do with negative exponents? Make it positive. And how do I make it positive? I don't just erase the negative. I have to do something. How do I make it positive? Move it to the bottom, exactly. So I'm going to leave my x to the 12th up there. The y to the 8th is coming down. How about this guy? Where's he going? He's going to the top. And x to the 8th is staying down there. All right, now let's look at this scenario. I got 12 x's over 8 x's.
4 x's.
It's 4 x's. And where would those 4 x's be? On the top. And I know they're on the top, gang, because there's 12 of them up here and only 8 of them on the bottom. So the overflow's on the top. How about my y's? Same thing. There's my answer. We need to get used to having problems with more than one step. We need to just do one step at a time until we finally get done. Okay? All right, let's do one more. Who else had a question about a homework problem? Maya?
53.
You said 53? Write the amount of revenue in dollars obtained from the source in scientific notation. So I got to use that chart right there. So the number that I'm doing in problem 53, which is federal, is 36930,338. That's the number that now I'm going to write in scientific notation. So remember, when you write a number in scientific notation, it's something times 10 to a power.
It's always 10 though, right?
It's always 10. That's always going to be a 10. That's never anything but 10. This number, whatever it ends up being, has to be between 1 and 10. So you have to rewrite this using these same digits. You have to move the decimal point, which is right there to start with. You have to move it until it becomes a number between 1 and 10. Well, that's pretty simple. Don't I want it there so I have a 3.6? So I'm going to move it. So it's going to become 3.6930338. Now that number is between 1 and 10. And I moved it 1, 2, 3, 4, 5, 6, 7 places. Anytime I'm moving the decimal 7 places, my exponent's going to be either positive 7 or negative 7. I can't remember moving right, left, up, down. I can't remember all that. I just know that if I have a big number, my exponent will be positive. So is the original number a big number? Yeah, so that's going to be times 10 to the 7th power.
In the back of the book, I'm having it to like the 10th power, which I'd be.
That's wrong. Yeah. It's okay, they make mistakes too. Okay? One more, then we really do have to get busy. So we'll do one more question. Who else had a question? Nothing? All right, then here's what we're going to do. I want you to put your notes away, put your papers away, and get out a half sheet of paper. Half sheet of paper, share with partners. How nice. You get short paper this time. Diego, half sheet of paper.
Suzanne, we should say we need to go to the. She just said she's not ready. Oh, sorry.
Okay. Here's what we're going to do. We got everything put away. We got out a half sheet of paper. Put your name in the upper right-hand corner. Right up here goes your name. Okay? I got it?
How did you do it? I need some pink.
Upper right hand corner.
We have a gum chewer in our midst.
I'll pray for you. She has a gum chewer.
Full size, non-generic box of Kleenex.
He said Kleenex. Oh my God.
Full size, big box.
Can we write on this?
Non-generic.
At least we are. She goes, I swear. Yeah, she seems smart. We all are smart. Don't want to do it again. Actually, get this one.
I'm going to put 2 problems on the board. You are going to work with your team on the problems. There is to be no talking. So you are going to have to somehow communicate with your partner without talking. There may only be one team at each table. So for example, I've got 2 teams at this table. One team is going to stay here. The other team is going to go sit in the back corner, sit in the closet, sit at this table, sit on the floor. We've got comfy chairs in the back. We're splitting up. Everybody is going to turn in a paper. Everybody put on the window. No book, no notes. This is a real quiz. You are just able to work with a partner on it. Got it? Okay, here are the problems. I'm putting them on the board.
Wait, are we allowed to like have a gap in between?
No, find a place. Sit on the floor back there. Sit here. Doesn't matter. Find a place. Two questions only.
Are we allowed to split them up?
No, work on them together. Each one of you has to answer both of these questions. This is not brain surgery. You guys can't see me really looking at this. Let me get up. And my gumshoe was Katie Roth, is that right? When you are finished, I want you to please just turn your paper over and wait quietly. There's supposed to be no talking, remember? There's too many of us to talk. When you're done, just sit patient. I have one more thing to tell you, and then we'll be ready to move on. Make sure you've compared with your partner and you guys match. I mean, obviously, you want to help each other. Okay, while you're finishing up, I want you to keep working, but keep in your, this is, I only want to talk about this once. Every time we take a quiz, and there'll be a lot, we have a lot of quizzes to kind of make sure we're all keeping up with stuff. Every time we have a quiz, I will say, who has a birthday bonus? Who wants to ask a birthday bonus? And what that means is, each one of you during the course of the year, one time gets to ask a bonus question. And you'll ask it of the whole class. The whole class will write down the answer, and anybody who gets it right gets 2 bonus points. So in a class of 28 kids, that's like 56 points I'm just gonna give you over the course of the year. You get one time to ask it. If you ask it on your birthday, so for example, if we have a quiz on your birthday, on your actual birthday, it's worth 4 points. So you should save your bonus question till it's time for your birthday, in case we have a quiz that day. Today, we're gonna have a birthday bonus, but it's gonna, do we have anybody whose birthday's today?
Mine was August 5th.
Okay, so we'll do yours today. It's only worth 2 points, but we'll do his today because it's passed, right? And then we'll do people in July and June, all the ones that are passed. But if your birthday's in April, you're gonna wanna save it till April, because trust me, by April, seniors, you're gonna need every point you can get your hands on. So we'll save them and use them then when it's close to your birthday, okay? Now, here's how this works. Jabron is going to ask the question. He may ask any question he wants, but it has to have to do with mathematics. He can make it as hard or as easy as he wants. Everybody is going to write the answer up by your name, and you're going to put a circle around it. So your name is already in the upper right-hand corner. Right under your name, you're going to put the answer to Jabron's question, and the question is?
1 times 1.
1 times 1 is your question. Up by your name with a circle around it.
Don't want to stop too many of you.
Everybody writes it down. Everybody gets 2 points. You write the answer with a circle around it. Now, Jabron has asked his question. He doesn't get another shot now. He's done. Next quiz will be somebody else, and so on until we get through the whole class. Okay?
So it could be like,
What?
like it could be a year or two since it's a number, right?
It has to have to do with mathematics. So somehow you have to have math involved in it. All right, let's have your papers. Let's go. Anybody want to go up and put number 1 on the board? I need number 1 on the board. Let's go. Who's going to put number 1 on the board? There you go, Katie Baumgartner. Who's going to put 2 on the board? Okay, you got 2. Alex got 2. Everybody back to your seats. Get your notes out. We'll take some notes today. Here we go.
Just right.
Make sure I have your kids.
Yeah.
All right, let's look at these kids. Let's look at these and make sure they're right. Would you agree this picture's correct?
Yes.
Let's see what happened here. This problem, it looks like whoever did this distributed the 2 first. You do not have to start that way, but it is a fine way to start. Then whoever did this moved some negatives around. So pulled this negative to the bottom. Said, look, I got 14 over 6. That's 8. I have 6 and 8, that's 14. Let me see if that's what I got. Is that what you got?
Wait, that was fun.
Yes. Good job. Everybody okay? All right, get your note sheets out. Let's go.
You just did one like that. Why do you have 1? Maybe we got that one looks really good.
What's the difference of flipping it here?
You did it yourself.
Did we not flip it on that problem?
We did.
We did?
You just put, you get
They brought the X to the 6 down.
Oh, we did it. We put the other one up there with it when we flipped it. Because I just remember. She remembers. You don't flip it. Yeah, that was my
Okay. Everybody's got your note sheets out. We need to finish up number 10, part 10. on page 2 of the note sheet, page 2, problem 10, properties. We didn't get to those. Yes, ma'am. Okay, we'll wait on 9. I gotta get 10 done, and then I gotta move on a little bit, but we'll come back and do 9. But first, we gotta do 10. We absolutely have to do 10, okay? Which property is illustrated? A is distributive. B.
That is the old associative.
No.
Commutative.
Commutative. Boys and girls, if the order has changed, it's commutative. When I look at problem B, one side of the equation has x plus y, the other side has y plus x. What happened? The order changed. When the order changes, it is commutative. Okay? So when I look at my problem, if the order has changed, it's commutative. Period. Now let's look at C. What happened in C? What?
Flip. I think my note sheet's in my last period.
It's too bad. Take a picture of somebody's and move on. C. What's going on there?
Associative property?
No, that's another commutative. The difference is, it's the commutative of multiplication. Because in C, the multiplication is in a different order. Listen as I read it out loud. 6 times x plus y times 6. Do you see how the multiplication is switched? In the one above it, it was the addition that was switched. So in the one above it, it was commutative for addition. In C, it's commutative for multiplication. Now, some of you are going to be confused by that, and you shouldn't be. When is it commutative? When the order changes. So if an order has changed, it's commutative. Period. D, there's not an order change there. We're adding 0. Anybody know what that's called?
Associative.
No. If you keep guessing, eventually something will be associative. What did you say? It's the identity property. Is it Bruns? Miss Bruns knew the answer. She said it's the identity property for addition. When you add 0, you get the identical thing. Identity. You get the identical thing when you add 0.
Like if we were answering this in like a test or quiz or something, would we have to put like identity of addition to get like?
Or you would say additive identity. I don't care as long as those 2 words are in there. It doesn't matter. Okay, let's look at E. Now.
Oh, English?
Let's look at E.
That's really sad that I heard that.
On one side of the equation, we have 6, 4, and 3.